Hi, I'm Russ Baker. We're going to talk about the concept of logarithms and their properties today. First, let's see what the definition of a logarithm is. If a to the k power equals x, then k equals the logarithm base a of x. A, k, and x are positive. A is not equal to 1. We call x the argument of the logarithm, and a is called the base. The reason we have used this is we need an expression that will allow us to write an equation that solves for a variable in an exponent. The first skill you really have to master with logarithms is conversion from exponential form into logarithmic form and back again. Let's practice. Here's 3 to the 4th power equals 81. If we're going to put this into logarithmic form, we know that the base is still going to be called the base, and so we'll write log base 3. The argument is here, 81 equals the exponent 4. From this we can understand that the logarithm, base 3 of 81, is 4. And so we get a very important idea right off the top that logarithms are exponents. That little phrase will help you with your conversions. Now let's see what we can do with this conversion idea by trying to evaluate a logarithm by putting it back into exponential form. Here's our problem. Log base 4 of the cube root of 4 divided by 2. Now, if we're going to put this in exponential form, we would probably put an x out here like that. Now we can change it back into exponential form. The base is 4. The logarithm is the exponent, x, equals the argument, cube root of 4 over 2, like so. Now the advantage we have in this special problem is that these numbers are all powers of 2. So we could write this as 2 squared to the x power. We could write this as the cube root of 4 is 2 squared, and the cube root is the 1/3 power. So that's 2 to the 2/3 power divided by 2. Now we could simplify our exponents. We can say that 2 to the 2x power is, now we're going to do 2 to the 2/3 power minus 1, because when we're dividing powers we subtract exponents, and so this will become 2 to the 2/3 minus 1, which is negative 1/3. We now see that if 2 to the 2x power is 2 to the negative 1/3 power, well, then 2x must be negative 1/3. Dividing both sides by 2, we would find that x, remember x is the evaluation of our logarithm, is negative 1/6. And that's the solution. Logarithms come in all bases. We can see that from our work with converting for exponents, but there are some common bases that are used more than others. Common logs have a base 10. Whenever we're using base 10 logs, we frequently will omit the base number and just write log. So if you ever see that log, you may assume that the base is 10. There's a log key on your calculator. The other common base that's used is called a natural log. It has base e. The way we express that is to write ln of x. Instead of log base e, we write ln of x. And there's also an ln, or natural log key, on your calculator. Let's see how we could use our calculator to evaluate the logarithm, base 10, of 28 to the third power, or the logarithm of 28 to the third power in natural logs. We'll move over to our graphing calculator and turn it on, and we'll push the log button first. That means we're doing a base 10 log of 28 raised to the third power. And we see that the answer is 4.34 with irrational numbered decimal places after that. Let's try the natural log of 28 raised to the third power, and we see that it will be a different value because it's based on a different number, 9.9966, and so on. Logarithms have many properties, all of which you should become familiar with. Let's look at some beginning ones and see what we can learn from them. Here are the first three properties of logarithms that you should know. If a is larger than 0 and a is not 1, then the log base a of 1 equals 0. That's saying that any base, the log of 1 is 0. Here's another important property. The log base a of a to some power is that exponent. Log base a of a to the k equals k. Also, if you have a to the log base a of k power, that is also equal to k if k is larger than 0. Now let's look at three other properties. Let's assume that x is larger than 0, y is larger than 0, and a is larger than 0 but not 1, and any real number r. These properties are respectively called the multiplication property, division property, and power property. Let's look at them. Log base a of the product of two numbers is equal to the logarithm, same base, of the first factor plus the logarithm base a of the second factor. The logarithm of a product is the sum of the logarithm of the numbers. In a similar fashion, the log of a quotient is the difference of the log of the two numbers. And finally, the power rule is that the log of any base of x to the r power is that exponent times the log of the base.